Okay, let's go ahead and get started. Welcome to the 9.1 Grand Tour. PostgreSQL 9.1 is out. This is my first chance to actually do a presentation after it's officially out. So everybody knew that 9.1 was out, right? Did you know before this morning? How many people have downloaded 9.1 or a beta or an RC? That's pretty, wow. So for a lot of you, this is going to be complete news, which is cool. I'm really excited about 9.1 because there's lots of stuff in there for me. And as a matter of fact, when I've been talking to other people and other clients, we actually have a probably scary number of clients who have been using 9.1 beta in staging, waiting for this Monday to deploy. And even one of them who's been using it in production. And a lot of it is because 9.1 has so many features that no matter what you use Postgres for, chances are there's at least one feature that you're going to discover you can't live without. So get prepared to upgrade. I expect next week to be really busy for me. So I can't talk about all of the features of 9.1 because it has so many features, but I'm going to talk a bunch about the major ones. So we're going to take a little bit of a tour here, a grand tour, and we're going to start out, I already talked a little about this, we're going to talk about synchronous replication and some of the new replication tools with some demos, and then talk briefly about per-column collations, and then WCTEs, and you'll learn what those are, and again with some demos, and then talk about SSI and unlogged tables, brief demo there. A little bit about SSD Postgres and k-nearest neighbor, SQL Med and foreign data wrappers, then on to extensions, and then we will have a brief airship flyby of a list of other features, and then finish up if we have time for questions or time to run off and drink beer with Heroku. So let's get going. So the first major feature, and the one that got the most attention about 9.1 is synchronous replication. Now, in 9.0, for our built-in binary replication, we have asynchronous replication. So now, I have here set up, and I'll show you this in the demo later, is I've set up a little cluster of 4 replicated servers. So we've got London, Paris, Madrid, and Berlin as our servers. And right now, so if we have them set up with asynchronous replication, then what happens is we get, somebody sends in a database, they send a database update, they send a write request. And then London will, which is the master, will acknowledge that write request, and then broadcast out copies of it to all of the asynchronous slaves. And in general, that works fine, unless something happens to London. Because if we have this happen where somebody sends in a write request to London, and London sends back an acknowledgement of that write request, and maybe gets as far as sending it to Berlin before the blitz happens, and then we lose London, and it's offline, then what's going to happen is the client application thinks their write has been saved. But if we promote Paris to the new master and we overwrite the data in Berlin, it's actually been lost. And if that data was really, really important, that's not really acceptable. You know? Or if you're running this in a set of cloud servers that have no durability, so you're never getting back the data out of London, that's not acceptable. So, synchronous replication to the rescue. And how synchronous replication is different is that we send the write request again to London, the master, and then it sends it out to all of the followers, and then London waits for the first synchronous replica follower, which in this case is Paris, to acknowledge it.
There can only be one synchronous.
Right. Well, the others are potentials.
But it's not whichever pre-response.
No, that's what I said. It's waiting for Paris to respond, specifically. It's waiting for Paris to respond, and then only then does it send the acknowledgement to the client. And so what this means is, if the write request comes in, and London has not passed it on to Paris before it goes offline, then the client never got an acknowledgement and it doesn't think its data is saved. It thinks it lost the connection and it needs to resend whenever we actually go through the failover procedure. So synchronous replication is a way to avoid losing data. Now, this confuses people a little bit because they think of synchronous replication as in a way to make sure that Paris is absolutely synchronized with London for load balancing purposes. But anytime there's a network involved, there's going to be some level of asynchronicity where you're not going to be able to see a very recent transaction on one server that's not saved on the other server, particularly if you have a failure in the middle. So synchronous replication is a way to avoid losing data. So now, one of the things that I find amazing and pleasant and thrilling about this is that unlike almost everything else we do in the PostgreSQL project, when we went ahead to implement synchronous replication, we actually implemented it in a pretty simple to configure way. That we did our long discussions, we actually ended up with something fairly simple and easy to understand. And I'll show you this again in the actual configuration files. But basically the idea is that, if you have your standby gets set up, and one of the things we added in 9.0 is this connection parameter called application name. Well, we're now using the application name on the replica to identify the replica to the master. So what you do is on the standby's replication configuration file is that, you make sure that it identifies itself. Oh, oops, sorry, this is supposed to say London, not John. And it identifies itself. And then the master can actually have a list of who are the synchronous replicas. And this is an ordered list. So it's waiting for a response from Paris until it decides that Paris is not going to respond. So so let me actually show you that in action here, which is much more fun. So let's see, what do we have? Yeah, screw that. So I set up, I do a lot of stuff in GoGrid these days. So set up a little cluster here. It's a little hard to read from the back, but this is our little cluster of replicated servers that we set up in GoGrid. And they're replicating here. And we've got, let me resize this. Hello. Thank you. So we're in London right now. And let's actually look at the configuration. So this is Ubuntu. So we actually go into the PostgreSQL.conf. So this is the master. And so we're going to have a bunch of configuration in PostgreSQL.conf. And there's going to be where we have right here, you can ignore this stuff. But down here is the important stuff. We were setting up replicating mode. We're doing some archiving. And that's mainly to enable remastering. And then we've got this whole master configuration that has information about how much logs to keep. And then here's the synchronous setup here. We've got our synchronous standby names, Paris, Madrid, Berlin, in that order. And then this configuration actually exists on the standbys, which just has, that they're hot standbys, so they're accepting queries, and their ability to delay replication slightly if they have a local conflict. Hello. Okay, and actually that's when you see this on one of the standbys. So let's look at Paris here. So again, here in Paris, all of this stuff is being done just through the connection of the streaming replication. So we're connecting to London as the master currently. Got port, replication user, and this application name of Paris so that we can identify which standby it is. So if we actually go into here, and here you'll see some of the other new features. If we actually go into here on London, which is the master, actually let's display this in landscape format. Well, you see one of the other features, which is a new replication view. So this is our new replication view, and this is actually showing you all the replicas that are currently connected to the master London. So this is Paris right here, which is our first replica. And we've got the setup, and this actually is it's a new feature, and it allows you to keep a lot better track of who your replicas are. So this shows you where the various write locations and that sort of thing are. It shows you what the priority is. Remember I said that's an ordered list of who you're trying to synchronize to, and you're just waiting for a response from the first one in that list, unless the first one in that list has been marked offline. So so it's the order of one, and this is in sync. Now, because the other two are not ordered, then Madrid there shows up as 2, and it's not showing up as sync because Paris is active. It's showing up as potential. So that is, we've configured it for synchronous replication, but it's not currently replicating synchronously because Paris is still active. Same thing with Berlin here. This has also helped a lot with monitoring, having this view, because you can actually do some of your checks on using the view. So streaming replication setup, and actually, let me show you what happens with synchronous replication here. Oh, wait. So we're going to now need to actually, so right here, it automatically detected that Paris had shut down. And so immediately Madrid becomes, the next one on the list becomes our sync slave. So, it's an example of that. So now, one of the things that Simon implemented for synchronous replication, yes? Yeah, because there's going to be a time window where, well, but the thing is there can't be any loss on synchronous transactions, because if Paris does not acknowledge a write, then that write does not get committed. Yes. Well, no, it has to be the first one in the list that's actually online. Yeah, because we don't want it to be indeterminate which one is synced. Because if you didn't know which one had synced, then you wouldn't know which one to promote to be the new master in the event that you lost the old master. So like in this case where I've taken Paris offline, it's only going to look for a sync response from Madrid. It's not going to care about a response from Berlin, because Berlin is not currently the synchronous slave. So now one of the other things that we implemented, or that Simon implemented actually, with some help from somebody in the back of the room here, was something that is unique to Postgres, which is that you can actually control whether or not stuff is synchronously replicating on a per session or per transaction basis. So the default for this setting synchronous commit. So previously synchronous commit was used just to detect whether or not you were synchronously committing to the local write-ahead logs. Well, now synchronous commit has two meanings. One is, are you synchronously committing to the local write-ahead logs, or are you synchronously committing to the synchronous standby slaves? So now, if you've got your default of setting synchronous commit to on, then that means if you've set up synchronous replication, you have a synchronous replication slave, then it's going to wait for a response from the synchronous replication slave before this commit returns. But, and that's a good idea to do if you've got important data, like, you know, you're changing people's account balances in your application. Then you want that to happen. But say your users are just sending messages. In that case, if you lose this in the event of a server loss, that's a write-off. You don't care if it's synchronously replicated. So there's a new potential setting for synchronous commit, which is local. And local says, commit it to the local transaction log, assuming you're using, you know, to the local transaction log, but don't wait for a synchronous acknowledgement from the standby server. And that way, if you have a large number of transactions to things like session logs and other information where a certain amount of data loss is acceptable, you can avoid paying the response time penalty for synchronous replication for that data and only pay it for the data that's really important. PostgreSQL is actually the only database that currently has this. Yeah? Unlocked tables don't replicate. And we'll go into that because unlocked tables are coming in later on. The it's a session, it's a user set variable. So you set it in your session whenever you want to. But it's going to affect the transactions after you set it until you change it again. Yeah. Yep. So, and you can do it in stored procedures for that matter. Okay. So I went over, I showed you one of the new tools, PGStat replication. Second new replication tool, PG-based backup. And that actually removes a lot of the pain of creating new standby clones. I'm not going to demo that because I've got, with Ubuntu putting things in 3 different directories, it's actually a little less single command than it ought to be. This actually, instead of you making SSH permissions and doing an rsync in order to make a clone of the master, what you do is you just run PG-based backup, and it connects to the master over the Postgres database port and copies everything. And then all you have to do is start the clone. So one of the other new features is that with some limitations, you can promote one of your standbys to be the new master. And this is something you'd actually really want to do in a setup like this, because the whole idea of having a designated synchronous standby is that if London goes down, because this is our synchronous standby, we want to promote that one to be the new master and then start replicating. And because it's our synchronous standby, we know that it is never going to be behind these two. You can do that. Now, the limitation that I said is that in order to do remastering, you have to be copying write-ahead log files as well as doing streaming replication. For 9.1, that's just a limitation. We don't have all the information we need for remastering in the socket replication stream. And so you have to also be archiving logs, unfortunately. Hopefully, we will change that for 9.2. There's also some new functions that have, for example, checking when our last replay was. Importantly, here's a really fun one. You can pause replication through administrative command on any standby. And where this becomes particularly useful is you're doing replication, but you want to do a PG dump. You want to do a backup. And you want to stop replication when you're doing a backup in the standby. Then you can actually do this to pause replication and then restart it once you're done doing the backup. Rather than needing to change your timeout and reload, which is a little bit more awkward. Yeah? Yeah, you don't want to do this in your synchronous standby. You want to do this in an asynchronous standby, yeah? Yes. Yeah, that's what remastering means. So yeah, I mean, you still need to change the connection information on the other standbys and restart them in order to have them connect. But then once they do, they can just start over. So lots of new goodness with replication. So next feature. This is more in the arena of something that people have been asking for a long time, because we have so many people using Postgres in so many different languages. And previously in Postgres, so we've supported lots of different encodings for a long time, but there's a concept called a collation, which determines how things are sorted within, say, text fields. And the problem is that for different languages, you want to have different collations. And previously in Postgres, you could only define this on a per database basis. So if you wanted to have a case like this, one column that was sorting in English and a second column that was sorting in Japanese, and that had, importantly, its indexes sorting in Japanese, you couldn't do it. Now you can. We have per column collations in Postgres. And you can actually have stuff that sorts in a correct order by index. There's actually a good example of that from Hubert, who actually created this as an example of his native language, Polish, of actually going into a database that was not created as Polish, setting up the Polish collation, and then being able to sort in correct order in Polish. So for anybody doing a multilingual database, this is pretty much essential, and it's good to finally get that out of the way. Now, we're headed for a much stranger place, what I call the land of surreal queries, where you will see bizarre and horrible things in SQL that you will nevertheless, in the future, find yourself addictively unable to avoid using. So, one of the things that we've got in 9.1 that's been worked on for a long time is actually something called writable CTEs. CD stands for Common Table Expression. Now, we got Common Table Expressions in 8.4, but they're pretty much read-only. Now, Postgres actually combines an earlier feature called returning, where you can return a set of results from a write query, with the ability to write in common table expressions to actually do interesting things. For example, imagine that I'm purging old posts from a forum, and I want to delete all posts over 6 months old, and when I delete them, I want to get back a list of how many posts per user I deleted. So this query does that. You delete the posts, you have it return the post that it's deleting, and then you actually do an aggregate query over the posts that you deleted. Seems pretty straightforward, not quite as surreal as we're going to get. Because the thing is that, what if, though, one of the things that I have on the home page in my application is a count of how many posts each user has? Well, I need to update that count now if I'm deleting queries. So what we're going to do is we're going to delete the queries and return this, and then we're going to sum the number that we're deleting from each user, and then we're going to subtract that from the count of posts per user. And this is all one statement. Fairly surreal, but not as surreal as we're going to get. So, this is my fun, surreal, writable CTE query. So what this does is this operates in a PGBench database. So you can try it and set it up on PGBench and that sort of thing. So what we're doing is we're coming up with a hypothetical situation where we find that we have a teller, because PGBench simulates a bank. So we have a teller in one bank branch who has been making up spurious transactions and adding them in. And so what we want to do is we want to back out all of their transactions out of the database. So what we're going to do first is we're going to delete the transactions out of the transaction history. And then we're going to take a sum of how much money that those transactions represented in positive and negative per account. And then we're going to take that and we're going to change all the account balances to reflect the backing out those transactions. And then of course, but we have branch balances too for each of the branches that those accounts are held at. So we need to actually sum up the balance per branch and then update the balance per branch according to the transactions that we're backing out, and then go ahead and return a list of what we did. So let's go ahead and run that, shall we? Okay, so that teller, as it turns out, actually didn't have very many transactions because we actually only ended up, well, actually, it makes sense. We only ended up updating one branch because we limited it to the teller at one branch. So this gives a list of, we just backed out $3,287 out of that branch in spurious transactions from backing out that teller stuff. And it did it all in one query, adjusting the balances for all of those things. So you can see the potential here both for simplifying application code and limiting round trips to the database, as well as for huge abuse in queries that never stop executing. But I predict that you will end up using them, because once you learn how to write them, they're so useful that you don't want to avoid them. And of course, this highly useful version of writable CTEs. We didn't invent writable CTEs. We're not the first database to implement some form of writable CTEs. But writable CTEs that can do as much as ours can, thanks partly to the insert, update, returning, delete returning, is a Postgres only feature. So, serialized snapshot isolation. Go over this just really briefly because it's actually a complicated topic, and for this reason, Kevin will be doing a full-length presentation tomorrow explaining this in more detail. But the essential idea is that how many people here have to deal with complicated multi-statement transactions in their application? Yes, that's a fair amount. And how many people here regularly have to troubleshoot deadlocks because of those, out of those? So a fair amount. So this is really a way to avoid deadlocks that you can't untangle. It's actually not really realistic to say no more deadlocks. But the idea is that if the transaction works in isolation, it will work concurrently or it will fail cleanly and can be retried. That's the idea. Now, in order to take advantage of this, you have to be operating in serializable mode, which does a lot more checking, has a lot more overhead than read committed mode, so you don't want to do that if you don't actually need this feature. But if you do need this feature, then you really need it, because you don't want to get stuff locked up. An example from Kevin's blog here is that, of something where read committed is a problem because you don't want both of these statements, there's no world in which both of these statements should succeed. Where one user, we've got two people in an Othello game, one user trying to change everything to white and the other one's trying to change everything to black. And there's no world in which both of those should succeed. So we run it in serializable mode, and what happens is, because the one changing everything to white commits first, then we get a serialization failure with the one trying to change everything to black. Because we detected it. And we detect this without the kind of locking overhead that you would get with pessimistic locking, with doing things like select for update. Anyway, little complicated to explain. Will be a full hour-long talk about this tomorrow by Kevin Grittner. If you're interested in this, if you have to deal with complicated multi-statement transactions, then go to that talk. Next part of the tour, unlogged tables. Had a couple questions about unlogged tables. I'll do this just briefly because Robert's going to present on them again tomorrow. The idea of unlogged tables is sometimes you have data that, if anything happens, you're just going to throw away. For example, you might be maintaining a session table, and if the database server goes down, you're not necessarily going to care about the state of people's sessions from half an hour ago when the database went down. Or more often, you might be doing an ETL procedure where your data exists in several transitional states, and if there's a failure in the middle, you're just going to start over from scratch. In that case, you really don't want to pay the I/O overhead of writing to the transaction log, because you're basically writing everything twice. So unlogged tables give you the opportunity to not write to the transaction log. So I just created this unlogged table. Now, unlogged tables have some interesting effects. One of them is, because the table is unlogged, and let's go ahead and log into Madrid here. So one of the questions was, what happens with unlogged tables and replication? Not PG bench. And what happens is this vaguely helpful error message that basically tells you you can't, because we're replicating via the transaction log, an unlogged table does not get replicated to the standby servers. And so if you attempt to access it in the standby servers, you're going to get an error message because it's not there. So it's one of the reasons why, an unlogged table is not just a go faster button. The second thing, of course, is if something happens to the master, we can do that a little bit more programmatically, actually. If we wait, not branch history. Copy history. And we have an empty table now. That's what unlogged means. So it's not just a go faster button, but it is very useful when your data is in fact disposable. So, next spot on the tour. Let's talk about SC Postgres a little bit. Another complicated topic. I don't have a demo for this one. So some of you may have noticed there's been talk for a couple of years about this SC Postgres thing and that sort of thing. The idea is that SC Postgres does tight integration between Postgres and SC Linux. The idea being that the SC Linux users can be your Postgres users, your permissions and priorities for SC Linux can be your permissions for PostgreSQL, applying to all objects. The idea being that, if you have a data system, often you will have data that's in the database and data that's not in the database. So data that exists in the form of files outside the database, data that exists in the form of tables in Postgres. And if you are the security administrator for a company that really, really cares about security, then you want to make sure that whatever permissions apply to the data, apply to it regardless of where the data is. That's the idea. And so how this got implemented in 9.1 is that we have hooks in the database system, depending on how your PostgreSQL was built. If you're getting it off Red Hat, it was built with that stuff there. But SE Postgres doesn't actually become active unless you load the module and restart Postgres. And then it actually becomes active.
When we create a one table in master, can we enforce to get a schema propagated to slave, not data, but still unlocked?
Yeah. We discussed doing that, but there wasn't much point because what good does it do to have a schema when you can't, it will never have any rows and you can't write to it on the standby. Yeah.
No, the table will be there on the slave after the slave is master. Okay. But it will be empty.
Yeah. Yep. Yep. Anyway, if you have more questions about that, go to Robert's briefing tomorrow. So, now we haven't implemented, the one thing that hasn't been implemented from SC Postgres is we're still working on row-level security because there's a whole bunch of specification issues with row-level security in order to figure out exactly how it should be implemented. But all of the other object permissions are implemented. If you are in the position, where you actually need to implement that level of security, and you know who you are, then there's a bunch of documentation on how to do this. And I'm not going to actually go over it here. So, next up, I want to talk about k-nearest neighbor. Now, I don't actually have a demo for this, so let me actually talk a little bit about this. The big excitement, so this is a new type of index access, a new type of index for Postgres. And the idea is that it actually indexes on distance, the abstract concept of distance. Now, one of the easiest ways to understand this is imagine we're on our grand tour, right? So we're taking a grand tour. And we get to Florence. And it's 35 Celsius out. And we missed breakfast. So we really, really want to get some gelato. So we take out our smartphone. And we want to know where the nearest gelato stand is. And we want to know really quickly. And so we can actually do that distance thing as an index search and not as the sort of approximate two-step search that's currently implemented in PostGIS to answer this sort of query. That it actually comes back and you can say, give me the top things that are closest to this. Now, distance is actually, let's see, do I have more about this? Yeah. And with a relatively simple query, like that. This is a demo query. It's not complicated once you've gone ahead and built the indexes. Now, this can actually get implemented for several different things. As a matter of fact, because PostGIS has not yet implemented, you can use it for point, actually, just out of the box with Postgres. But in the PostGIS package, they haven't yet officially implemented support for k-nearest neighbor. But one of the things that comes with Postgres is trigram, which is a way of searching for approximate matching in text. Like, if I'm looking for, if people are looking for me and they want to find BIRKUS and BERKIS and all of these other sort of, misspellings, then that's also another abstract concept of distance. And so we have a new trigram implementation in Postgres that actually uses the k-nearest neighbor to search for the nearest matches to text. And actually, I'm not sure. I need to look at whether or not Microsoft released before we did. It was a bit of a dead heat there. But we were working on this at the same time. The only other database that actually has this feature was working on it. Now let's talk a little bit about extensions, because I need to use them in the remaining feature. Not this kind of extensions, of course, but rather this kind of extension. Now, Postgres for a long time has had a lot of optional modules. How many people have installed a contrib module or an optional data type in Postgres? So how many people have upgraded Postgres with a contrib module or an optional data type? Was that fun? That's been a problem for a while, because the problem is that with all these Postgres extensions in the past, once you installed them, Postgres had no real knowledge of their relationship to each other, or of maybe wanting to upgrade the optional module itself. So thanks to Dimitri's work on this, we now have this concept called extension. This is an example of installing the case-insensitive text extension, which, if you install your sort of contrib packages on there, is just available. So all you have to do is type create extension. If not, create extension if not exists is actually a good way to do it if you're doing it in a deployment script, in case it's already installed. CI text, and then you get this nice sort of view, which is even accessible through PSQL with the DX switch, of the extensions that you currently have installed, and even what version they are, because we have a concept that extensions have listed versions, so that you know whether or not you've updated to the correct version of that extension, because a lot of them are being developed. This is part of our super extensibility that exists only in Postgres. The more important things about this is your ability to remove extensions in one statement, or if the extension maintainer has supplied the upgrade scripts as part of the extension packages, even upgrade the extension to a new version, independently of upgrading Postgres. So I'll demonstrate that with the next feature. The other exciting thing about extensions, at least for me, I'm a little involved in this, is that we've set up, David Wheeler has set up the PostgreSQL Extension Network, which is an online repository of extensions in handy downloadable packaged form for installing them as Postgres extensions. And in the future, we'll be hitting up for a lot of volunteers to actually start doing binary builds of these extensions, because right now they're just in source code form, which is kind of a pain if you don't have a compiler handy on the system, like you're in Windows. But there's a whole bunch of stuff there. There's going to be more stuff in the future of all kinds of handy stuff that allows you to avoid writing your own code for customizing Postgres. So let me talk about the other feature that I'm going to demonstrate with this, and this is SQL Med, or the new feature in 9.1, which is FDWs, foreign read data wrappers. Sorry. And the basic idea of a foreign data wrapper is to give PostgreSQL the ability to access external data to the database as if it was a table within the database. Whether it's another Postgres database, whether it's Oracle or MySQL or something else, whether it might be tabularly formatted files. Anything that anybody has written a driver for. And with the arrival of Postgres 9.1, we have a number of drivers, including what ships with Postgres is Andrew's file FTW driver. Well, it's not yours, really.
No, mine Pegasus extension.
Okay, so yours is in the on PG. Okay, so there's a file FTW for comma separated value files that ships with Postgres, but on PGXN and elsewhere, people have already put drivers for Oracle, MySQL, CouchDB. Somebody did one for Twitter, so you can actually run queries against Twitter. But let's actually demonstrate some of this stuff. It's more fun to demonstrate it. So let's actually do this for the file FTW. So the first thing that we need to do is let's first of all let's see whether or not we have the extension. So the extension's actually already been installed here. Otherwise, I would just do. So I would just need to do that. But I don't actually need to do that because it's already installed. So let's make this just a little bit bigger, huh? So let's go ahead and actually add a foreign data wrapper to a file. Now, one of the first things, I think is, okay, we need a source of data. We need a comma-separated value file. What's a good comma-separated value file? Well, one of my favorite things to spend a lot of time messing around with, which is the PostgreSQL logs in CSV format. So we're going to go ahead and create those as a data source. So, get that open. So we got a couple of these. So now one of the first things that you have to do after you have the data wrapper available is you actually have to create a foreign data server, which is sort of a confusing concept when we're dealing with text files. It doesn't make much sense. But if you consider that FDWs can be used to connect to something like an Oracle database, where you would actually have a server that has several tables on it, it makes more sense. Ah, okay. Sorry, it looks like I already created that. So, and then the next thing that you actually do is that you need to actually create the foreign table. So you do this with the create foreign table statement. Now, and because Postgres does not have metadata about the foreign table, in your declaration, you need to actually define the metadata. And so this example is actually available in the PostgreSQL documentation. So this is just the definition for using the PostgreSQL logs. And here we have, here's the important thing, is we're going to connect to the file name in here relative to the PG data home directory. Okay, let's do that again. Ooh. Well, this is the RC. Okay. That's not very useful. Let's do it in landscape format. So now we can actually look at what's in our log for Postgres. And so we've got some errors that I got on startup and that sort of thing. And you can actually query this, query for particular things. So like, hold on. And so you can actually get, treat it just like you would a table and query for particular things. A lot more fun than parsing the logs with grep. So let's go back to our grand tour, because we're almost done here and almost out of time. Now there's actually, Dave Page is giving a talk tomorrow that involves SQL Med rather heavily. So you can go and see that if you're actually more interested in this. So let's do a quick flyby on some other features because we're almost out of time. There's been an overhaul of PL Python to actually fix a bunch of issues and make it much more performant. Valid on creation foreign keys is a big issue for data loading. Extensible enums. Anybody here use enums in Postgres? Right. Well, I know you do. Well, one of the things, I've actually stayed away from using enums in Postgres because one of the problems has been, what if I need to add an extra value to the enum? In earlier versions of Postgres, that would mean actually rebuilding the table. Now you can just add it, and even add it in the middle. The triggers on views, you now have a different way to make views updatable. Instead of needing to understand Postgres' rule system, you can do something about putting a trigger on it. Trigram already talked about. We've reduced the storage size of numeric, which is important for a lot of people with data warehouses. For some alter types, we can now change data types for a table where the storage format is identical without rewriting the table, which is really important if you want to, say, change varchar 32 to varchar 64 without rewriting the table. And then pgdump directory format in order to, as sort of a precursor to parallel pgdump. No. No, because it still understands the larger size. And it's actually only reduced, as I understand, it's only reduced size if the number itself is very small.
No, it's actually if the number is not ridiculously large.
Right.
It's something like it shares 2 bytes off numbers with more than 500 significant digits.
Yeah. So, but until you actually, so what will happen is if you rewrite the data, then you'll get the smaller size. But if you just PG upgrade it, you won't get the smaller size until the rows are rewritten for some other reason. So that's the end of our tour. So you can actually learn more about some of these features. The unlogged tables, we've got accelerating local search, PostgreSQL at the center of your Dataverse, true serializable transactions are here. We've got a bunch of sessions tomorrow. Unfortunately, some of them at the same time, explaining some PostgreSQL 9.1 features so you can learn a lot more. And that's actually all for our tour. We're back home. Thank you for flying with PostgreSQL Airlines, and we hope that you had a good time. Thanks.